All right, basic constructions. Now, this might be a little different than a lot of math you're used to in previous years. Excuse me. The point of this is to be able to draw some stuff with shapes and do some things to shapes without having to measure. Now, I say that, but we're going to have a ruler, but I'm not going to measure with it. I'm just going to use it to draw straight lines. This is the sort of thing they have to do for blueprints and construction before we had computers. Now, the first construction, construct the bisector of each angle. When you bisect something, you cut it in half. Now, what you do to bisect, to cut an angle in half, we're going to center our compass, that's what this is called, into the corner, the vertex of the angle. And we're going to draw an arc, which is just a curved line, part of a circle, so that it hits the two lines that form the angle. Then from each of those intersections, around the center here, without changing the compass, we're going to make a little curvy X. So again, I drew one big arc so that it hit each line of the angle. And then from those intersections where my curve or my arc hits the line, I draw two little curvy sections that form an X. Now, the reason that we do this, I'm going to connect the vertex to where my X connects. The reason this works to cut the angle in half. We draw these so that they're both the same distance from the vertex. And then the intersection of this X is the same distance, since I'm not changing my compass, from each of those points. And then you connect the vertex, which is at the center of the angle, to this point here, which is the same distance from the sides. So this is in the middle, that's in the middle. You form a whole line that goes down the middle. You don't have to remember why it works. No, it's just the explanation. So again, center your compass, the sharp point on the vertex, corner of the angle. Draw an arc so it goes through both lines. And then from each of those intersections, draw part of an arc so that you form a curvy X. And then connect the vertex to the intersection on your X. Now in class, what we did was I did the first two, then I let people try the next two. I'll just do one more. Now, if, let's say after you draw your first arc, if you go to do the curvy X thing and they don't touch, then you can keep your first arc, just make your compass bigger, but don't change it in between each side, and then you can finish that construction off. Again, that's only if they're not going to touch. Most of the time, you'll be okay. So that was an angle bisector. Now, perpendicular bisector. We're still cutting the shape in half, but instead of an angle, it's a line this time. Perpendicular, two lines that are perpendicular, they form a right angle, a 90-degree angle. Now, for this one, and you can just kind of eyeball this, you go to each end of your line segment, but your compass has to be more than half. And yeah, that's more than half. You can draw one arc from that side. You can do about a half a circle. Go to the other side of your line segment without changing your compass. Draw another about a half circle. Now, the whole reason this works, we're the same distance from this end, and you're the same distance from that end. So we're right in between. And then we connect them. Perpendicular line cuts it in half. So same idea. Make sure, oops, there goes my straight edge. Well, that's only about half. We got to be at least a little bit beyond halfway. There's one. There's the other. And then connect the points of intersection. Oops, I missed. That's a weird roll. Let me pick up the better one. Let's try this again. Since I missed the other intersection. There we go. And one last example here. You go from one end of the segment, go from the other end of the segment, don't change the compass in between, connect where your two arcs intersect. All right, so that was the perpendicular bisector of a line segment. Now, number 9 says construct a line segment perpendicular to the segment given through the given point. So we still want a perpendicular line, but instead of just cutting this segment in half, we want to go through this point. So this adds an extra step here. What we're going to do first is we're going to center our compass on that point. And then make sure you're not bigger than the line. Just draw a circle. And sometimes it is easier to spin your paper than to try to move the compass. The reason we do that is now we have like our own little line segment we made where that point is directly in the middle. So then we can just do the same thing we just did. Make sure you open your compass a little bit. And there we go. Now, number 10, same thing here. Draw a circle first. Now, again, the reason that works, we have narrowed this down to just this segment of the entire line. And since I drew the circle from the center, this is the middle. So then, perpendicular bisector of the segment we made will go right through that point. All right. That was pretty similar to the one we just did, so I'll just do 2 of that one. Just remember, draw a circle first, centered on that point. Now here, the same instructions, but now we want a perpendicular line through this point, which is not on the line. And this one's bit different. Center your compass on that point, and we want to draw an arc so that it goes through twice, the line twice. Then, this part's similar to the ones we did earlier. You go from each of those intersections. Do the curvy X thing again. This works because same distance to there from the dot, same distance to there from the dot, then same distance again from each side. So this is right in the middle, and connect it to that. Connect it to the original dot through the original point. All right. Same one here. We want a line that goes through twice. Oh, just barely, but I got it right there. And then go to the other point of intersection right about there. Draw your curvy X. And where the curvy X crosses, connect. And I'll do another one of those. So you want it to go through the line twice. You may have to adjust your compass a little bit. There we go. Now from each of those points of intersection where your curve hits the line, center on each one, draw a little bit of the arc to make the curved X, and then connect the original point, the original dot, to your curvy X. All right. Now the next three. This is probably the hardest one out of all the basic constructions here. We want a perpendicular line to this line through the point, but it's on the end. So here's how this one works. And again, this is one of the more confusing ones for people. So somewhere in the line here, above or below it on either side, put a point. Don't do it right here on the end. Can't do it out there. Just somewhere in the range, kind of in between the line here, put a dot, either above or below it. You don't want it too close to the end point, because then it'll be hard to use your compass because it'll be so small. You want to center your compass on your point, not the end point. That was a mistake that people made in class, is that they tried to draw the circle here. You want it here. You want your pencil lead on the compass to go through the end point. Draw a circle. Now, where this circle hits your line, sorry, I keep hitting my camera base here. So where my circle hit the line, I'm going to draw right from that point, go through the center dot to the other side. And then if I connect this, where this line hits the circle, down to the original dot in the question, I have a perpendicular line. So again, somewhere inside the line on either side, put a dot. Center your compass on that dot. Then your pencil lead should touch the end point that was in the problem. Draw a circle. Now, where your circle hit the original line, we're going to draw a line from that intersection through the center. Then, where this hits the other side, connect that to the original dot. You got yourself perpendicular line. One more. So somewhere above or below the line. And nope, gotta make my compass a little bit smaller here. All right, now we're good. Draw your circle. Again, make sure that your point of your compass, the center of your compass, is on your dot, not the dot in the question. Then, where that circle hit the line, go from that point right through the center. Then connect where that line hits the circle to the original dot. Perpendicular. And if you want to, you can make it bigger. Okay. All right. What do we have left here? 3 more, I think? Yep, 3 more. We spread these out over 2 days, and after the first half, the first day, I gave out some practice ones for everyone just to sit there and try and get help on. I'll just go through this whole thing. Now, 21 says construct a line segment congruent, meaning equal to each line segment given. So what we do, draw a line anywhere, about the same length, make it a little bit bigger. And again, the point of this is to not measure. This is what they would have to do to with blueprints when they would enlarge stuff. But anyway, this one's a direct copy. So after you draw your point, after you draw your line, center your compass on one end and then open it up so it is the length of the original line. Go to either end, put a little mark there. So center it on one of the ends, put a mark there. This copies the length from the original to that segment. You don't have to erase that. You put 2 dots here. That shows whoever's grading it, hey, that's my answer. So again, draw a line. Then center your compass on one end of the original line segment. Open it up so it measures that length. Transfer it down. And then you got yourself a copied line segment. One more. Draw your line. Open up your compass so that it is the length of the original line segment. Go to either side. Here, this time I'll do it on the other side. Use my left hand here. There we go. Again, these dots, you don't really have to put them on there. That's just to show this is my copy. That's my leftover work. All right. Now, the next one is an angle copy. First thing you do, draw a line. Doesn't have to be the same length. Now, go back to their original angle. Center your compass on the vertex corner. Draw an arc so it hits both sides that form the angle. Just like that first one we did at first. Go down here then. Leaving your compass the same, draw an arc. Now, what we got to figure out is where to put the top part of our angle here. So I needed an exact spot on the bottom, which I've copied down here, to get a reference to place the top. So we'll open it up to where that hits on the original. And then if we go down, center our compass where our arc intersect our line and draw that in. That's the same distance. So then all I have to do, connect end to that intersection, copy the angle. So again, draw a line, then go to their angle and draw an arc so that it hits twice, hits both of those. Come down about the same place, do about the same size of an arc. Then go back. Oh, you gotta open it up a little bit so that I measure the distance from this intersection to that intersection, transfer it down here, and then that tells us how to finish this off. Same idea. Even though this angle's more open, it's more obtuse, we are going to draw an arc so that it hits twice. Forgot to draw a line first. I'm going to be careful not to change my compass so I don't have to redo that. Now, look, it's going to hit over here to the left of the end here, the vertex. So when I draw it on my line, I know I have to go longer than I did on those top ones. Then same idea, I need from this point to where the line hits my arc. So right there, transfer that on down. Oh, there we go. Copy the angle. And one more. All right. So, first thing we're going to do, we're going to pick one of the sides. I'll pick the bottom. And we'll copy that. So we draw a line and come up, measure that out. We just did this construction a couple ago. There. So right here and right here are a copy of the bottom of the triangle. Now all I really need is to find the top vertex here. And that's going to be this far away from the bottom left side, which I've already copied. So I'll measure that. We'll come over here, draw an arc. Oop, that wasn't very dark. Let's see. There. So then wherever these two distances meet, so now I'm measuring the right side, wherever those two distances meet, that's that corner. That's that top vertex. Since I found that, I can just connect each side. And there we go. $30. Pick a side. All right, well, I'll pick, a lot of people in class pick the bottom right here. Doesn't even have to be at the same angle. I just kind of approximated it to make this look good. There we go. So now I've copied the bottom right. So I need this other vertex. So I've copied this side. So let's see how far, and that's about that. Now, what some people did today is that they did it down here and it flipped the triangle over. That's fine. I'll do it that way. So then we need the length of the other side. There we go. They flipped the triangle over. It still copied it. All the sides are still the same length. You just connect there to there and there to there. That's fine. I could have drawn that very first side vertically if I wanted to for some reason. I'm still copying the triangle. It's just kind of moved, rotated around. So I'll copy the bottom here. Draw a line in. That one's obviously too big, but it doesn't matter. So measure out the side that you picked first. There we go. Now measure out the other two sides to that vertex. There we go. There's one. Go to the other. Measure the other side. There's that. Oh, I didn't really hit. Got to go back now. We'll make that one bigger. There we go. And there you have it.